All right, so let's talk about relationships and constraints. We're looking at these relationships of one-to-many, right, and how we would capture that. Obviously, we might find as we reinterpret the phrases that there might be actually more than just one noun, actually more like 3 or 4, and how we would reify that into to capture that and implement that in a relational schema. But notice that when we did the conversion between this conceptual model above and converted into this reified, more concrete representation, we kind of lost some of the constraints that we had originally. In the original diagram, we kind of had the constraint that for any two combination of section and student, you can only possibly have one grade, right? That we weren't able to enforce that in this new representation, right? There's nothing stopping us here from having one particular combination of section and student with one grade, and then having later on another same student, same section, but a different grade, right? Over here in this representation, we could not do that, right? Because any two combinations, you can only possibly have one grade. Whereas over here, there's no enforcement of that constraint. Okay. Right. So we lost that, right? The constraint here was implied, right? Whereas over here, we're not. There's no way for us to disallow it, right? But what we could do is perhaps take the two foreign keys, right, that refer to the student and the section, and we can combine that into a compound foreign key, right? So that instead of just being one each separately, we can combine them, and this way we can enforce the fact, right, that this cannot repeat. The combination of a student and a section cannot repeat. So in that way, we kind of can go back and enforce some of the same constraints that we had originally. That the combination of those two will enforce it. Okay. It says general principle assumes reify tail has. Now this is the case that when you do the conversion between this and go here, right? You can enforce the same implied constraint, right? If in the resulting table you have the original keys, right, that you would have needed to implement the previous one, right? And here we do, right? We to implement this, I need, this star kind of tells me that I need a foreign key that goes to the student, and this kind of tells me that I need a foreign key that goes to the section, right? So I have the original keys and to implement the relationship. So since I have them, well, I can combine them. I can combine them and enforce the uniqueness of that relationship. But you don't always have that, right? You don't always. That's not always the case, right? So the principle kind of assumes that you have it, right? But it could have been that once you did the reification and did the conversion, you might have come into a redundancy, right? And now that you have a redundancy, you decide that I already have this attribute represented in this other field, right? And because I'm representing it twice, you might decide that I want to get rid of one, right? Because you already have a field that captures that information that was not in the original diagram, right? So you might remove it, and then you're left without being able to enforce the uniqueness. Okay, so here's another example where we're considering other constraints, right? Other constraints that alternate constraints that we could have been in the narrative, but there weren't. Good. We got lucky, right? So for instance, this might have been a requirement in the narrative. that says a student can enroll in a section of a course only if the student has not taken that course before. Meaning you cannot take the same course. Once you've taken it, you can't take it again. All right? So that was not in the original requirement. Okay? So somehow now we have to kind of remember, right? We kind of have to remember that you have already taken this course, right? And you can no longer take it again, right? So in that case, not only do we have this three-way relationship between a student, a section, and a course, I need to somehow remember, right, that there's for a particular course, I might have multiple sections, right? So that now becomes a three-way relationship between, right? It used to be just a student and section, right? That one student can be in many sections, and one section can be many students can be in that section. But we like to be able to enforce the fact that if you have already taken that course, right, you cannot enroll, because this one doesn't allow us to do that a student can be multiple times in the same section. That is disallowed, right? You cannot be in the same section twice. But nothing is stopping you from being in another section for the same course, right? Nothing is stopping you from doing that. But if we want to be able to enforce that, somehow we need to capture and say that, hey, wait a minute, there is a relationship between student and course, not only between student and section, right? This we already had, right? One section can have many students, one student can have many sections. And we already had the fact that one course has many sections. We already had that, right? So this we already had. Yes, we already have that. What we didn't have is that somehow we need to remember that there's something to do between a student and a course. Somewhere we need to capture the fact that you have already taken that course, right? That's a relationship that was not there, right? We didn't. Actually, I think we had removed it. Maybe it was that at some point we removed it, right? Because there was some redundancy. But now, right, because of this relationship, because of this constraint that we need to capture somehow, remember that there was some relationship between a student and a course. We need to capture this somewhere, right? That there is a relationship. If it's already there, we don't want to capture. We don't want to let you enroll in that section. So if we reify that, right? If we reify this enrolls in, right, and convert that into a mapping table that has references to the student, the section, and the course, we end up with something like this, right? That we have an enrollment table in there. We get this, right? We have a student, a course, right, pointing to the in the section. These are all foreign keys, but we also say that we're applying here the uniqueness between a student ID and a course. What else are we having here? We have a section that has a primary key and it references a course, meaning you can have multiple sections for a given course, and the student and the course. Okay. Right. So the principle says that if we want to enforce the enrollment, because we have access to the original keys, right, we can combine them to enforce uniqueness, right? That if you were already in a particular student in a particular course, you cannot have them again, right? It's unique. You cannot have the same student in the same course again, right? That's how we are enforcing it, right? By taking the student and the course and making it unique. But notice that because of that new requirement, we find that the relationship between enrollment and course is redundant, right? We can ask the same kind of thing between section and course, right? You can navigate from enroll to section to course to be the same way you can navigate from enrollment to course. So we have with this new requirement, right? We have introduced redundancy, right? We have introduced the risk of inconsistency, that we're capturing the same information twice, right? That we can navigate both ways, from enrollment to course or following enrollment section and course. So basically we think we can either go from the enrollment of the course, or we can go enrollment section course, right? We have the same type of information, right? So we're kind of like stuck in between. So do we want to enforce the uniqueness that was in the original data model, right? If we don't enforce it, right, we would be allowing folks to enroll. We wouldn't be able to enforce the fact that you should not enroll in a course more than once if you've already been there, right? We would be allowing some ambiguous, right, or inaccurate information, right, that somebody was able to enroll in the course more than once. But if we add the constraint, then we're allowing redundancy. So we're adding the risk of inconsistency. So there's no way to go both ways. You can't have it both ways, right? Either way, you would be allowing some misinformation or capturing something that is not true, right? And one of them is that you would be allowing folks to enroll more than once. In the other one, you have redundancy, right? So you're kind of in a conundrum, and you don't have a good option, right? You can either just live with the risk of inconsistency, or you can live with the fact of just bad data, right? And you just have some social knowledge in the institution that you know that there might be some inconsistent data in there, and just live with it. Or you can use store procedures or allow or implement some of those rules at the application level. Have the application level make those decisions, right? And before allowing a student to enroll in a course, the application could query, and say, oh, has this student been enrolled in this course before? And then the API would allow you to say, well, no, well, okay, then let them register. Otherwise, don't let them register. Right? So we need some programmatic way of solving this, right? There's no way to solve it with just constraints, right? With just constraints. So we'll look at. There's no good choice between these two evils, and so we'll have to deal with it either at the application level or with stored procedures.